Recording in progress.
Hey guys, once again, this is Mr. D of DSS Review Center. And today I will be teaching you a particular lesson on coordinate geometry. Specifically, we will be discussing the distance between 2 points. First, let us have the distance formula. When and how do we use the distance formula? Okay, take a look at these three given points. So I have here point A at 4, 3, point B at 1, 1, and point C at 4, 0. When we are solving for the distance, let's say we are solving for the distance between two aligned points, let's say A and C. If they are aligned either vertically or horizontally, all we have to do is to count the number of units. So from here, we have 1, 2, 3. So that means the distance between A and C is 3 units. However, when we are looking for the distance between A and B, we cannot simply count the units because they are not aligned. The distance from this point up to this point is not 1 unit anymore. It is more than 1. Remember, this is already the hypotenuse side. So in that case, we need a specific formula to be able to identify the exact distance from A to B and B to C. And to do that, it is important for you to know this formula. So if A is a point, point 1 representing X and Y, and B is X sub 2, Y sub 2, or two any points on the Cartesian plane, then AB, the distance from A to B, is equal to the square root of x2 minus x1 squared plus y sub 2 minus y sub 1 squared. Okay, so how are we going to apply it in this case? All right, so let's say to find the distance between two given points on the Cartesian plane, you may consider the procedure below. Number one, determine the x and y coordinates of the points. Number two, substitute the coordinates of the distance or to the distance formula. And finally, simplify your answers. All right? So let us say we are to solve for the length of AB, BC, and AC. Okay? Let's start with AB. So to look for or to find the distance from A to B, we will be needing these points, A and B. So we represent x1 for 4 and y1 for 3. x2 is 1, y2 is 1. Okay, so point 1 or point 2. That's why they are represented by x1, y1 because a point is represented by x and y values so that we can be able to locate that on the Cartesian plane. So in that case, to solve for A, B, these are the values we need. Okay, so all we have to do is to substitute these values to the formula. Okay, so in that case, x sub 2 here is 1, x sub 1 is 4, so it becomes 1 minus 4 squared, while y sub 2 is 1 and y sub 1 is 3. That's why it becomes 1 minus 3 squared. Okay, when we simplify this, we know that 1 minus 3 is, 1 minus 4 is negative 3 squared, and 1 minus 2 is negative 2 squared. Negative 3 times negative 3 is positive 9. Negative 2 times negative 2 is positive 4. That's why the distance from A to B is square root of 13 units. So the distance from this point A to B is square root of 13 units. So most of the time we write our answers in radical forms for uh, checking. Okay. However, if you really need the distance, then you may convert this into decimal points. So in that case, you will be needing a calculator to be able to simplify that easily. Okay. So let's proceed to example number 2. So how do we solve for BC? Again, to solve for B and C, or the distance BC, just represent. So I may use point B as x1, y1 and point C as x2, y2. This may be interchanged. This could be your x1, y1, and this could be your x2, y2, depending on the way you substitute it to the formula. You will get the same answer anyway. All right, so solution, x1, as you notice here, is 1, y1 is also 1. X2 is 4 and y2 is 0. So substitute once again these values to the formula. Then we will have, okay, these values. 4 minus 1 is 3, 3 squared, okay? And then 0 minus 1 is negative 1 squared. When we simplify 3 squared, it will be positive 9. And negative 1 squared is positive 1. So the distance from B to C is square root of 10 units. So the distance from BC or BC is actually square root of 10 units. Okay? So, and finally, for AC, so we are to look for distance AC. As I mentioned earlier, that if they are aligned, we can simply count the number of units. So 1, 2, 3. That means the distance from A to C is 3 units. Okay, but just to verify if the formula is consistent, then we may substitute for point A, x1, y1, for point C, x2, y2. Okay, so these are the values. Let's double check once again. X1 is 4, y1 is 3, x2 is 4, y2 is 0. Okay, and then substitute these values to the formula. Then we will have 4 minus 4 and 0 minus 3 squared. And then 4 minus 4 is 0. 0 minus 3 is negative 3. So that's why 0 squared is 0. 3 squared or negative 3 squared is 9. That's why AC is square root of 9. But what is the square root of 9? Okay, correct. So that's actually 3 units. So that justifies our answers, that even if we simply count the number of units, if 2 points are aligned on the Cartesian plane, whether vertically or horizontally, we can still get the same values. Okay, so I hope you like and understand this particular video about distance formula. And once again, I'll be uploading more videos for grade 10 lessons. So for those who have not yet subscribed, please subscribe so that you will always be updated. Thank you and have a good day.